Okay, we will wait for 1 minute more. Let us see whether someone else joins or not, and then we will start. Ayush, no need to give the attendance here. We will take the IMCRP exam, and then you can give the attendance. Okay, so let us start then. It's already 9:31. Okay, so before starting off, just a small discussion, or you may say announcement. The first thing is you must already be familiar that Wong ma'am, me as well as Saurabh sir takes your networking theory classes. So Wong ma'am follows a different classroom, right? And me and Saurabh sir follow a different classroom. So you must be aware of that. Just tell me a yes or no.
Yes, sir.
Yes, sir. Okay. So in our classroom, the classroom that me and Saurav sir follow, we have given the syllabus for your mid-sem exams. Have you seen it?
Yes.
Yes. Okay. Acha, one more thing regarding your CA2 marks. Wong ma'am gives you assignment, and based on the assignments, she grades your CA1, CA2 marks, right? But generally, Saurabh sir also gives assignment. I don't give any assignments. But generally, what we do is based on your IMCRP exams, IMCRP attendance, we give the marks. But from now on, we have decided that we will take a small exam, MCQ exam. There will be 10 questions maximum, and it will be of 20 marks. And based on the performance in that exam, we will give the CA2 marks. Okay. So we have two options. So the first option is that we can either take the exam on Sunday, that is on the 23rd. So the exam link will be valid throughout Sunday, and you will be able to log in and give the exam. It will be a normal Google form, not through IMCRP. Okay. So this is the first option. The second option is your mid-sem exams for computer networking is on the 27th, I guess, right? And from the 25th you are having your exam. So the 26th is the holiday, right? So again, to not give much load to you, so normally you will be studying on the 26th for your networking exams on the 27th. So again on the 26th we can conduct the exam. So whatever you say, we can do that. So we are just taking suggestions. So your section B, again tomorrow I have a class with section A. From section A also I will take the suggestion, and then we will decide. So what do you say? Just tell me. So on the 23rd or on the 26th? If any one of you can respond.
Sir, I joined just now. Can you repeat what you said?
Okay, actually we are planning to take an exam, right? A small exam, sort of quiz of 10 questions that will be of 20 marks. And based on that, me and Saurabh sir generally, we will give the your attendance for CA2, right? Uh, your attendance in IMCRP as well as your performance IMCRP will hold some value, but the maximum value will be on this question, on this exam. Okay. So we have two options for you. Either on Sunday we can have this exam, that is on the 23rd. Also 26th is a holiday, and on the 27th you have your networking exams for your midsems, right? So anyways you will be studying for your midsem exams on the 26th, right? So again we can have the exam on 26th as well. So either 23rd or on 26th. We are just taking suggestions. Tomorrow I will be having a class with section A as well, so I will again take the suggestions from them as well. So what do you say? You will be comfortable with 23rd or on the 26th?
Sir, I think 26 sounds better.
26 sounds better. Okay, so you do one thing, you decide amongst yourself. Okay, and any one of you can just WhatsApp me the tentative date that you are comfortable with. Okay, so just discuss amongst yourselves and then let me know. Okay, and then me and Saurabh sir will sit and discuss, and then we will let you know what's the final date. Okay. Okay, so these were the two announcements. So okay, let us start with the exam. Let us start with the class for today. Just a second. Okay, I guess you can see my screen. Okay, so in the previous class, obviously if you remember, we studied the basics of error control. Someone's mic is okay. Okay, thank you. Okay, so in the previous class, what we did is we started with the basics of error control, error detection, error correction. We told you what are the types of errors. It can be single bit errors, it can be multiple bit errors, as well as it can be burst errors. Okay, and also we have shown you some coding schemes, like what these are the coding schemes. These tables are the coding schemes actually, and we told you that using these coding schemes, we can again use these coding schemes to generally detect the error, or we can use these coding schemes to generally correct the error. Okay, also we studied the basics of the concepts of what is a data word and what's a code word, right? And we studied the basics of what's a redundant bit. So again, if I add redundant bits to the data word, it becomes a code word. So we have seen these kind of things. Okay, now again in the previous class we said that so whenever we were studying the error detection part, so using this coding scheme, we said that this coding scheme was could be used to detect what, only one bit errors, right? If there were 2-bit errors, then it would be difficult for this coding scheme to detect the errors, right? Similarly, we said that using this coding scheme, we said that okay, we can detect only 2-bit errors or 1-bit errors, right? If the errors were more than 2 bits, then it would become difficult for us to detect the error using this coding scheme. Okay, now so how can we, just looking at the coding scheme, how can we find out that okay, this coding scheme is designed to find out how many errors, how many bits of errors? So we can find it out, and let us see how. Okay, so for that we will study something called as a Hamming distance. Okay, now what's the Hamming distance? Let us understand. So if you see the diagram above, it is just a XOR operation. So again, if you see that if the bits are similar, if 2 bits are similar, it's a 0. If 2 bits are dissimilar, it's a 1. Okay, now again, if suppose I am adding 2 datas, right? Just look at the second part of the diagram. So if suppose I'm adding 2 data, so suppose the first data is 10110 and the second data is 11100. So again, if I add them using the XOR operation, so again you can see that 00, since the bits are similar, it's 0. For the second bit, the bits are dissimilar, so it's a 1, right? Similarly, for the third bits, the bits are similar, it's 0. For the fourth bits, the bits are dissimilar, it's a 1. And lastly, for the last bits, the bits are again similar, so it's a 0. So again, you can understand that how an XOR operation works, and how whenever we are having some data, having 2 datas, so how we can use the XOR operation to find out the resultant data. Okay, now what's the Hamming distance? Let us understand. So the Hamming distance is nothing but it is a distance between two words in and it means that it's the number of differences between between the corresponding bits. Okay, so which means if I have this data, just see the diagram, the second part. So if I have the first data like this, and if I have the second data like this, if I find the Hamming distance generally what it means, what, that it is the distance between these two data. Now what's the distance? It is actually the number of differences between the corresponding bits. Okay, now let us understand how do we take it further. Okay, now let us find the Hamming distance between two pair of words. Okay, now again, if suppose there are two pair of words like 000 and 011, so again using the XOR operation, we can see that the result is what, 011, right? Now whenever we say Hamming distance, we will just count the number of ones. So in this case, if the number of ones are 2, we will say that the Hamming distance is 2. Am I clear with this? So So in the diagram for the second part, if I say what's the Hamming distance between these two data, we will say it's 2. Why? Because there are two number of ones. Okay. Similarly, so what's the one? It means that whenever doing the XOR operation, it means that the data are different, right? But whenever the data are same, the bits are same, and since we are doing the XOR operation, it will be a 0. So we will just say that whatever number of ones are there in the result, we will say that that's the Hamming distance, or that's the different bits in the both the data. Okay. So again, if I find the Hamming distance between 0, 0, 0 and 0, 1, 1, the result after the XOR operation is what? 0, 1, 1, and we will say that the Hamming distance of these two data is actually 2. Why? Because there are two ones in the result. Okay. So I hope it is clear till this. Now, now again, if I find the Hamming distance between 1, 0, 1, 0, 1 and 1, 1, 1, 1, 0, now again the result is what? 0, 1, 0, 1, 1. But again, we can say that the Hamming distance between these two words are actually what? 3. Why? Because there are 3 number of ones in the result. Okay. Also, there is a concept called as a minimum Hamming distance. Okay. Now, what's the minimum Hamming distance? So suppose we have multiple datas, right? And suppose we will find the Hamming distance between all the datas, right? And whenever we find the minimum, so suppose we have 10 datas, and we try and find out the Hamming distance between all the datas, right? And we see that after finding out the Hamming distance between all the datas, we say that the minimum number is 3, for example. We find out that, right? So again, we will see that for these datas, for all these datas, what is the minimum Hamming distance? It is 3. Now let us understand how do we actually calculate that. Now, so again, we can see that the minimum Hamming distance is nothing but it is the smallest Hamming distance between all possible pairs in a set of words. Okay. Now, so let us, if we see this example, so what's the question? That find out the minimum Hamming distance of the coding scheme in table. Okay. So again, if you remember, this is the coding scheme that we followed for error detection in the previous class. Okay. Now, what are the code words? It is 0, 0, 0, 0, 1, 1, 1, 0, 1 and 1, 1, 0, right? So what we will do is, we will just find the Hamming distance of 0, 0, 0 with 0, 1, 1, 0, 0, 0 with 1, 0, 1 and 0, 0, 0, 0, 0, 0 with 1, 1, 0, right? So between all possible pairs, we will find out the Hamming distance. So again, you can see that the Hamming distance between 0, 0, 0 and 0, 1, 1 is actually 2, right? Again, 0, 0, 0 and 1, 0, 1 is 2. Again, we can see that 0, 0, 0 and 1, 1, 0, the last row is actually 2, right? And similarly, we find the Hamming distance between all possible pairs in the code words. Okay. And after finding out all the Hamming distance, we can see that the minimum Hamming distance that we have for this scheme is actually 2. So we can say that the Hamming distance D, minimum Hamming distance, so D min in this case is what? 2. Right? Okay. So just leave it at this, and we will just move on to the next slide, and then again we will wrap it up. Okay. So similarly, if you remember this coding scheme that we use for the error correction, so again what we will do is we will find out the Hamming distance between all the possible pairs in the code words. Okay. So again, if we find out, so you can see the diagram given below, where we have found out what the minimum and the Hamming distances between all the code words or possible pair of code words in this coding scheme. Okay. So again, we can see that the minimum Hamming distance that we have found for this coding scheme is actually 3. So we can say that D min for this coding scheme, this coding scheme that is shown in the table, is actually what? It is 3. Okay. Now, what do we mean by minimum Hamming distance? For the previous coding scheme it is 2, for this coding scheme it is 3. So what do we actually mean by this? Now let us understand. It means that, just see the first point, to guarantee the detection of up to S errors, so if S number of errors we need to detect, the minimum Hamming distance in the block code must be D min of S plus 1. So it means if we want to detect 2 bits of errors, the minimum Hamming distance should be what? 3. If we want to detect 3 bits of errors, the minimum Hamming distance should be what? 4. Similarly, if we want to detect 1 bit of error, the minimum Hamming distance is actually 2. So again, if I go to the previous scheme like this, if you just see the error detection code word that we had, we can find that the D min in for this coding scheme is actually 2, which means using this coding scheme, we can find only 1 bit error. So if you just go to your previous class, you just see the recordings, we told you that using this coding scheme we can just find 1 bit of errors. If there were 2 bit of errors, then this coding scheme was unable to detect that error, right? So just refer to your previous class slides. Okay. Similarly, again, if you refer to your previous class slides, you can see that we have said that using this coding scheme for the correction method. So using this coding scheme, we can only find 2 bits of errors. If there were more than 2 bits of errors, then this algorithm or this coding scheme was unable to detect that. So again, we can see that the d mean for this coding scheme is again 3. So again, if it is 3, it means I can find out d mean minus 1 bits of error. So I can find out 3 minus 1, that is 2 bits of errors using this coding scheme. Okay. So I hope it is clear till this. Okay. Now, so after finding out that using this coding scheme, how can we find out the number of errors that this coding scheme can detect? So again, after this, we will go to the actually error detection parts. Okay. So again, in the previous class, we said that we showed you a sample coding scheme by which we can detect the errors. But again, we said that there are multiple algorithms that we actually follow in our day-to-day lives to detect the errors. Right now, generally there are 4 types of algorithms that we use in the case of error detection. So the first one is known as single parity check. The second one is known as nothing but a two-dimensional parity check, 2D parity check. So this can be called as a single parity check, or in many books you will find it as 1D parity check. So one-dimensional parity check. Okay. So we can call it a single bit parity check or a 1D parity check. Then we can have a 2D parity check. Next we will have something called as a checksum, and lastly we will have something called as a cyclic redundancy code, or which means actually CRC. Okay. Now let us see these one by one, and let us see whether we can complete this or not. Okay. So again, if I come to the single parity check, now what does parity mean? We need to understand first. Okay. Now the parity in this case means the number of ones. Okay. Now how do we do this? Let us understand. So blocks of data from the source are subjected to a check bit or parity bit generator form, where a parity is, so generally if I am adding parity to the data, so which means if I am adding a 1 parity, it means that the block contains odd number of ones. So if you have a data block and the data block contains odd number of ones, we will just add the parity bit 1 to the data. Okay. Again, if the data contains even number of ones, we will just add a 0 parity bit to the data, right? So odd number of ones, we will add a 1. If there are even number of ones, we will add a 0. Okay, I hope it is clear to everyone. So which means for every data we have, we will just add what? We will just add a parity bit to the data, right? Now what's the parity bit? It will calculate the number of ones. So if the number of ones are odd in number, so we will add a 1 parity bit, and if the number of ones are even in number, we will just add a 0 parity bit. Okay. So I hope it is clear till this. Now, so what happens is, if you see this diagram below, so you will be able to understand the flow chart. So at the center side, we have the actual data. Now we compute the parity bit for the data, and suppose we compute the parity bit as 1. So what do we do is, before sending the data to the receiver side, we will just add this parity bit to the actual data. So again, you can see the actual data was 1000011. So again, we have 1000011, and suppose 1 is the parity bit, so we will add the 1 parity bit to the actual data, right? Now again, this data is sent to the transmission media to the receiver side. Now after the receiver receives this data, so again the receiver will receive the actual data along with the parity bit. So what it will do is, it will calculate from the actual data, it will calculate the parity bit, right? Now again, if the parity bit mismatches, so suppose from this data it has calculated that the parity bit should be 0, but again it is finding out that the parity bit is actually a 1, which means that the parity bit is mismatching, which means there is some error in the data, right? But again, if the parity bit is the same, it will say that there is no error in the data, and it will accept the data. Okay. Now again, let us see an example, and it will be much more clearer to you. Just a second. Okay. So so let us understand what are the drawbacks of single parity check. Now you can see that it can detect only single bit errors, which means if I see this example, the previous example, So again we can see that there are odd number of ones at the sender side, so we are adding a 1, right? But at the receiver side, suppose the second 0 becomes a 1, right? So if the second 0 becomes a 1, the parity bit will change to a 0, right? So it can detect that a single bit of 1 has been changed to 0. Why? Because the parity bit will not be the same, right? Because if the second bit of 0 becomes a 1, the number of ones becomes what? Even. So again, if the number of 1 becomes even, then the parity will become what? 0. Now again, the receiver will find that, okay, the sender is sending me parity bit of 1, but here I am calculating the parity bit to be a 0, right? Now again, if the parity bit mismatches, I will say that there is an error in the data, right? And I will not accept the data. But suppose the second bit of 0 changes to 1, that is fine. But again, the fifth bit of 1, suppose it changes to a 0, right? So again, a 0 changes to a 1, and again a 1 changes to a 0, right? Now if this happens, what will be the parity bit? So the number of ones in this case will be again odd, so the parity bit will be what? A 1. Now again, if the receiver calculates the parity bit, there are 2 bits of errors in the data. The receiver calculates the parity bit to be a 1. So again, it will check that, okay, I am calculating the parity bit to be a 1, and the sender is sending me the parity bit of 1. So again, there is no error in the data. So what it will do, it will receive it will accept the erroneous data, which means if there is only 1 bit of error, single parity check will work, right? But again, if there are 2 bits of errors, the single parity check will not work. So again, you can see this example. So this 0 has become a 1, and again this 0 has become a 1. So again, if I check, so the number of ones in this case is in the sender side is what? Number of ones is actually 1, so it is an odd number, so it is a 1, right? Now again, at the receiver side, if there are 2 bits of errors, so again if we calculate the number of ones, it is 3, so again it's an odd number, so the parity bit is a 1. So again, if I am checking the parity bits for the errors, in this scenario, if there are 2 bits of errors, I will not be able to detect that there is an error in the data. Okay, so I hope it is clear to everyone. Okay, now we come to the 2-dimensional parity check. Okay, so in this 2-dimensional parity check, let us understand what happens. So in the previous scenario, we saw that whenever we have a block of data, we were just calculating the parity bit of that data, right? But in this scenario, just see the diagram and you will be able to understand better that suppose we have 24 bits of data. So what do? We will just arrange the 24 bits of data into frames of 8 bits, right? And what do? Is we will just arrange the 8 bits in a hierarchical manner, right, like this, right? And what do? Is we will calculate the parity for the rows as well as we will calculate the parities for the columns as well. Okay, so again for the first row, the number of ones are even are odd, so again we are adding the parity bit of 1, right? In the second case also, we have the number of ones as 1, 2, 3, 4, 5, so again it is an odd number, so we are adding 1, right? Similarly for the third row, the number of ones are 4, so it's an even number, so we are adding what? A 0, right? And for the last row of data, so again we can see the number of ones are odd, so we are adding 1, right? Similarly for the columns as well, we can see that in the first column we are having 2 ones, so it is a even number, so we are adding a 0, right? Again for the second column we are having 3 ones, so it's a odd number and we are adding a 1, and so on, right? So you can understand what is happening here. Okay, now what we will send to the receiver side. So along with the data, along with the suppose the first row, so we are sending 1 1 0 0 1 1 1 0, right? And along with the first row we will send the 1 as well, so we will send the parity bit as well, right? Similarly for the second frame of data, so we are sending 1 0 1 1 1 0 1 0, and along with that we are sending what? A 1, right? Similarly for the third frame of data, we are sending what? 0 1 1 1 0 0 1 0, and along with that we are sending the parity bit as well, right? So we are sending 4 frames, and all of these 4 frames will have 1 extra bits to show the parity for the row. And lastly, after we are done sending all these rows with the parity bits, we will just send the last row as well, that in which we have calculated the column parities. So again with this data we are sending what? 0 1 0 1 0 1 0 and a 1. Okay, Now again, when we receive this data at the receiver side, what will the receiver do? The receiver will just arrange the data in a hierarchical fashion, and it will just check for the errors. Okay, it will just check for the mismatch in the parity bits. Okay, now let us understand how. Now, so suppose the receiver receives this data and it arranges it in a hierarchical fashion like this, right? Now again, suppose in the
Sir,
tell me.
the corner at the both where both the rows and columns are meeting, that one you have written.
In this slide.
Now, just the last, I mean, the last block,
Okay, yes. Tell me.
and that one you have written,
Mhm.
and that is because on top there are three ones, and
Yes.
horizontally also there are three ones. Now, will it be like this only?
No. Actually, we will just see it for the horizontal one, not for the vertical one. Okay.
Oh,
So
okay,
which means
okay,
after we have calculated the column parities, so we will just check the row for the column parities. Okay. And in this row we can see that there are odd number of ones. So for this we have taken this as 1, not for the vertical ones, just for the horizontal one.
okay, sir.
Okay. 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 Now suppose in the second frame we are having the data having the error in the third bit. Okay. So you can see that suppose 0 in the second row is actually the erroneous bit. Okay. Now what will happen in this case? So after the receiver just arranges the data in a hierarchical fashion, again it will calculate for the parities, and again it will check whether the parity calculations are matching or not. Now again, if it is seeing that again for the second row, it is seeing that the parity bit is not matching, right? Again for the third column, it is saying that the parity bit is not matching. Now if I just intersect this, so we can see that we can accurately detect that which bit is erroneous. Okay. Now what is this? This is for a single bit error, right? So if there is a single bit error, it's very easy to detect the error using a 2D parity check, as well as we can also use it for correcting the error, right? But suppose if there are 2 bits, if there is a 2-bit error, so if it's a multi-bit error or if it's a burst error, let us see what happens. So again, you can see that in the first row we are having a mismatch in the parity, right? Also in the first column we are having a mismatch in the parity, right? Also for the third row we are having a mismatch in parity, and also for the fifth column we are having a mismatch in the parity. Okay. Now let us suppose that for the first row the first bit is erroneous, and for the last row the last bit is erroneous. Okay. So again, using this method we are able to detect the errors, we are able to pinpoint the errors, but whenever we are pinpointing the errors, we can see that other 2 bits are again getting intersected, right? And they are getting intersected wrongfully. It's a wrong. There are no errors in this data, but again using this method we are incorrectly intersecting this and we are pinpointing the errors. Okay. So again, if I want to correct the errors, we will correct it, and again the actual data will be will not be the same that has been sent by the sender. Okay. So which means if I am having 2 bits of errors, then again it becomes very difficult for us to detect errors using this method. Okay. So these methods are very good for 1-bit errors, but again whenever we are having a 2-bit error, it becomes very difficult for correcting the error. Okay. Okay, I hope I was clear till this. Okay. Again, another method that we have is called as a checksum method, and this method is actually very interesting. So the checksum is used in the internet by several protocols, although not at the data link layer, right? Which means we are saying that error control is generally a responsibility of the data link layer, but again we can use checksum for error detection, but again checksum is not a part of the data link layer, but still we use it. Okay. So again we need to understand what's the checksum. However, okay, so for error detections by checksums, data is divided into fixed size frames or segments. So again in the 2D parity check also we saw that whenever we have a data, we will obviously divide the data into frames so that we can arrange them hierarchically, right? Also again in the checksum also we will follow the same method where what we will do, whenever we will have a data, we will divide the data into multiple frames, and obviously we need to see that the frames should have equal number of bits. Okay, so which means the number of bits should be even, and whatever number of frames we have, we should always check that the number of bits in every frame are equal. Okay, so this is the first thing. So what happens at the sender side, let us understand. So the sender adds the segments, so it will add the frames or the segments using a ones complement arithmetic to get the sum. Now what's the one complement arithmetic, we'll see in the example. Okay, so again it uses the one complement arithmetic to add what, to add all the frames that it has divided the data into, and it will get a sum, right? So what will it do with the sum? It will just complement, it will just ones complement, which what is the ones complement, if you remember, if you know. So whenever we have a 0, we will just convert it to 1, and whenever we will have a 1, we will just convert it into a 0. So we will just do the ones complement of the sum that we have got using the ones complement arithmetic, and we will just send this. So we will call this as the checksum, and we will send this to the receiver side along with the data frames. Okay, now what will the receiver do? The receiver will again, it will add up the incoming segments using the ones complement arithmetic, and then it will just do the ones complement, right? Now if the result is all zeros, we will say that the received frames are acceptable, and if the results are not all zeros, we will say that received frames are not acceptable and it will be discarded. Now let us understand how do we actually do this. Okay, so we have this example for you, but again since we are working from home, I do not have the pen tab with me, so I will again use a Word document to make you understand the example. So just bear with me, it can take some time, but again just bear with me. Okay, so again if you see this, is it visible to everyone? Just confirm.
Yes, sir.
Yes. Okay, so again whenever we are doing a ones complement addition, so let us understand the rules first. So first and foremost, if we have two zeros, it's a 0, right? If we are having a 0 and a 1, it's a 1. If we are having 1 and a 0, it's a 1. So up till this, the rules are very much simple. Okay, now if I am having a 1 and a 1, so if I add them, it's actually a 10. Okay, and if I add 10 with a 1, it's actually 11. Okay, so just remember this, and it will help you in doing the problem of the checksum. Okay, now as we have discussed earlier, that whenever we have a data, we will just divide it into fixed size frames. Okay, so again you can see that we are having a 24-bit data in this case, and again in this case we can see that we have broken it down into 4 frames of 8 bits each, right? Now what we will do is, at the sender side, what we will do is, we will just add the frames one by one. Okay, so initially what we will do is, we will just add the first frame or the second frame. Okay, so if I come to the addition, just let me, just a second. Okay, so if I come to the addition, see, if I am adding the first 2 bits, that is if I am adding this 0 and this 0, so what's the result? It's a, tell me what's the result?
So 0.
0. Okay, for the next bit, what's the result?
1.
Okay, for the next bit, what's the result?
1.
1. Okay, for the next bit,
0 and carry 1.
0 and carry will be 1. Okay, again for the next bit we will have 2 zeros, which means it's a 0,
1.
but
1.
we have a carry 1, so we'll add that carry, so it will be a 1, right? Okay, next we have a 1 and a 0, so it will be a 1, right? Next we have a 1 and a 0, so it will be a 1, and lastly we will have double 2 1, so it will be what? A 10, like this, right? I hope I'm clear till this.
Yes.
Yes. Okay.
Yes, sir.
Okay. Okay. So again we can see that if I count the bits, so it is 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So we already have 8 bits for the addition, and we have 8 bits here. But again we can see that there is a 1 extra bit, that's the 9th bit, and that is the last one that we have. Okay. So again we had this as the carry, but again since we did not have anything to add it to, we just wrote that one to the result. Okay. Now this one should not be there, right? It should be of 8 bits, but the result now is of 9 bits. So what we will do is, we will just take this one, right, and we will add it to the resultant data. So what we will do is, we will just add this to this. Okay. Now again, if I just do this, okay, what happened? I don't understand. Okay, anyways. Okay, so if I do this, so what will happen? So 1 and 0 will be a 1, right? Then we will have a 1, then we will have a 1. So these things will not change, right? So then we will have a 0, then we will have a 1, then we will have a 1, then we will have a 1, and lastly we will have a 0, like this. I hope it is clear till this. Okay.
Yes, sir.
Yes, sir.
Okay, okay. Now to this, what we will add? We will add this. So we will add 1, 1, 1, 1, 0, 0, 0, 0. Okay, so just let me give spaces very quickly. And okay, like this. Okay. So okay. So what will happen here? So we will have 1 and a 0 is a 0. Okay. Then we will again have 1 and a 0 is a 0. Then again we will have 1 and a 0 it's a 0. Sorry, what I'm saying. So first and foremost
One,
it's a
sir.
1, it's a 1, it's a 1, right? Okay. Then we will have a 0 and a 0, so it's a 0. Okay. Then we will have 1 and a 1, so it's a 0, carry will be 1. Then again we have 1 and a 1, so again it's a 10, and if we add 1, if we add the 1 carry, so it will be what? 11, right? So just see this very carefully. So for this 1 and a 1, so for this 1 and this 1 we had what? 10, right? So again it's a 0, carry will be 1. For this 1 and this 1, sorry, for this 1 and this 1, what's the result? It's a 10, and if we add the carry 1, so it's a 11, right? So again we will have what? We will have the 1 and 1 will be carry. Okay. Again we will have 1 and a 1, so it's a 10. If we add 1, it's a 11, so again we have a 1 and 1 will be carry. Okay. And lastly we have 0 and a 1, so it's a 1, but again we have the carry bit 1, so it's a 10. So we will have 0 and we will have a extra 1 like this. Just a second. Yes, like this. I hope it is clear till this. If you have any problems, tell me. Everyone, is it clear?
Yes.
Yes, sir.
Yes, okay. So again
Yes, sir.
yes, okay. So again we have this extra 1, so what we will do, we will just add this. So we will add 1 to this. Okay, and let us see what's the result. Okay, so what's the result in this case? It will be 1 and 1 will be a 0, carry will be 1, right? Then again 1 and carry bit 1 is actually a 10, so we will have 0, carry is a 1. Again we will have, so 1 plus carry bit 1, it's a 10, so it will be a 0, and the carry bit will be 1. Again we have a 0, so if we add the carry bit 1 to the 0, we will have a 1, right? And lastly everything will be the same, so it will be a 0, it will be a 1, it will be a 1, it will be a 0, like this. Okay, is it clear till this?
Yes, sir.
Okay. Now to this what we will add? We will add the last one, so that is 1 1 0 0 0 0 1 1. So very quickly let me give the spaces. Okay, and again if we add this, so let us see what happens. So 1 and 0 will be 1, 1 and 0 will be 1, 0 and 0 will be 0. Okay, 1 and 0 will be 1, 0 and 0 will be a 0, 1 and 0 will be a 1, 1 and 1 will be 0, carry will be 1, and again 1 and 0 will be 1. We have a carry bit 1, so it's a 10, so it will be 0, and lastly we will have extra 1 like this. Right? Okay. So what we will do, since we have the extra,
Sir,
tell me.
sir, can you repeat the last sum?
Okay. So for the first bit, that is 1 and a 0, it's a 1, right?
Sir, no, not it, sir. The last sum 10110 with plus 1.
Oh, 10110 with plus 1. Okay. Did I do something wrong? Okay, let's understand.
No, sir. Just I am confused.
Okay. So 1 and 1 is a 10, right?
Yes.
So again we will have this 0 and carry will be 1. Okay. So again I will have this 1, and we have an extra
One,
carry
one,
bit, so 1 and
zero.
1 will be 0. So again we will have a carry bit 1. Okay, so again 1 and this carry bit 1 will be a 0. So again carry bit will be 1, right? So again with
Yes.
this 0 we will add the carry bit 1, so it will be 1, and rest will be the same because we don't have anything to anything else to add.
Yes.
Okay.
Okay, sir.
Okay, so for the last bit we had a 1 and a 0, it's a 1, 1 and a 0, it's a 1, 0 and 0, it's a 0, 1 and 0, it's a 1, 0 and 0, it's a 0, 1 and 0 is a 1, 1 and 1 is actually 10, so we have a 0, carry is 1, 1 and a 0 is a 1, so 1 plus carry bit 1 is 10, so we have a 10, right? And lastly what we will do, we will add the extra 1 to the data. Like this, okay. Okay, and if I add this, so 1 and 1 will be 0, carry is 1, so again 1 and 1 will be 0, carry is 1, it will be 1, and rest will be the same, I guess. Yes, like this. Okay, is it clear till this?
Yes.
Yes, sir.
Yes, sir.
Okay. Now at the center side, so what is this? This is actually the result of the addition, right? Now what do we do next? We will do the ones complement of this number. So it will be 0, it will be 0, 1, 1, 0, 1, 1, sorry, 0. Let me check. So 0, 1, 1, 0, 1. Okay, then it's a 0, it's a 0, it's a 1, it's a 1, right? So that's the thing. If you can confirm whether I have done it correctly or not.
Yes, sir.
Yes, okay. Now what do we call this? We call this as the checksum. We call this number as the checksum. Okay. Now what do? We will just take this checksum and we will add it to this data. So we will just add it to this data, right? And we will send this whole data. We will send this whole data to the receiver side. Okay. Now, so after receiving this data, the receiver what it will do? It will just again it will just continue the addition. Okay. So again it will add the first and the second frames. Okay. So if it adds the first and the second frames, the result will be this. Right? Am I clear till this?
Yes, sir.
Okay, okay. So again to the result it will add the third frame, right? So if it adds the third frame, the result will be this. Okay. Then it will add the fourth frame to this result. The result will be this. Okay. So after to this result, it will add what? This one. Okay. So let us see how we add it. So let us understand. Okay. So we have 1 0 0 1 0 1 1 0 0. So this data, right? And to this we will add what? This data. The checksum that we had. So we will add 0 1 1 0 1 0 0 1 1. Right? So again, is it clear till this?
Yes, sir.
Okay. So again, if we add this, what's the result? Tell me. It will be all will be 1, right?
Yes, sir.
Right? Okay. So if all will be 1s, and again if I do the 1's complement, so then what will happen? All will be 0s, right?
Yes, sir.
Okay. And if you see this, if the result is all 0s, then the received frames are accepted, otherwise they are discarded. Which means if the results are all 0, we can see that there is no error in the data, and since there are no errors in the data, we can find out that all the calculations lead us to a 0, right? But if suppose there were some bits that will change using this method, whenever we are transmitting this to the receiver side, if some of the bits change, then after addition, after this whole concept of checksum, after this whole computation of checksum, the resultant will not be all 0s. So if the resultant is not all 0s, the data will be discarded. Okay. So what you will do is, you have this example with you, right? And what you will do is you will just try and change 1 to 2 bits, right? And then do the calculation and then see what happens. Okay. I can guarantee that, not I, but the method can guarantee that the result will not be all 0s. Okay. So if the result is all 0s, there is no error. But the result is, if the result is not all 0s, there are some errors in the data. Okay. I hope I'm clear till this.
Yes, sir.
Okay. The next example is a CRC, but again it's 10:15, so I don't think I will be able to complete it. So again for the CRC as well, we had this kind of things. So I have prepared this Word file for you, and again I was just planning to show this to you using the same method in which we showed the checksum. Okay, but so it's already 10:15, so it would be kind of late if I want to show this. Okay, so anyways, so if you have any problems with today's class, just ask me if you have any questions till now. Anyone?
Sir, in mid-sem from your portion, we have up to which topic?
Just a second. Okay, so can you see this?
Oh, sorry, I didn't notice it was there in the class.
Yes. So this is my topic. My topic.
Okay, sir.
Okay. Okay. So also,
Sir,
tell me.
it says exam code not found.
Exam code not found.
Yes, sir.
What exam code are you trying to? Which exam code are you? Just tell me the number.
Sir, yours.
8268 at the last.
Oh, sorry, sir.
Ah, right. Yes. Okay. Okay. So I will stop presenting first. And okay. So you have your exam codes with you. You have your classroom codes. Kindly join the classrooms. Also, there was a message in the groups yesterday as well that kindly join the exam classrooms as well. Many of you have not joined, so kindly do that. That's very important. And okay, so it's already 10:16. The class is till 10:20. So I would request you to go and give your IMCRP exams, and I will be here till 10:30. Your IMCRP exams are till 10:30. So again, if you are facing any problems in giving the exam, just come to this meeting or WhatsApp me, citing your enrollment number, and I will just unlock you, and then you can give the exam. Okay, because attendance is taken by this by this IMCRP, and it's mandatory. Okay, so kindly go and give the exams. If you have any problems with today's class, stay back, ask me. If not, go back and give the exams. Okay, thank you.
Thank you,
Yes,
sir.
yes, okay.